Our next topic is structure of a magnet. To understand the structure of a magnet, take a white sheet and keep the bar magnet. This is a bar magnet. Okay, bar magnet fixed on it. Now sprinkle. These are the iron filling. Sprinkle the iron fillings over the magnet. Now the bar magnet attract iron filling most at the two end. That shows that magnetic power is stronger at the end. If you see here, at the end of a south pole and the end of a north pole, here there is a large numbers of iron filling are collected, and on the south pole also large numbers of iron fillings get collected. But here the rest area, there is a particular pattern that is going from north end to the south end. If you notice the direction of that iron filling, it's like this comes from the north end and ends at the south pole, like this. All are in the same way. That means a magnet having two poles, north pole and south pole. This show that the structure of a magnet. Next is, what are the properties of a magnet? Here we can say that a freely suspended magnet. This is a magnet that is suspended by the help of a thread to a pole. Okay. So freely suspended magnet always lies in north and south direction. This is the first property of a magnet. For this, tie a bar magnet and suspend it freely. Then it observe that bar magnet always stays in north and south direction. These directions are given, and when we match this, we can see that the north pole lies in north direction, that is same, and south pole lies in south direction. That means whenever you suspend a magnet freely, like in this way, it always stays or align in north and south direction. Even if you rotate it after some time, again it will align in north and south direction. This is the directive properties of a magnet that help to find out the direction, because as I said, magnet has two poles and it always stays in north and south direction. Next property is, north or south pole of a magnet cannot be isolated or separated. Let's say you have a magnet. This is a magnet that having north pole and south pole. So what do you think if I break a magnet into two parts? So do you think that a broken part of a magnet act as a north pole and other acts as a south pole? No. If you see here, if you break a magnet from here, this part, the south pole acts like a complete magnet. That means in this portion we get a complete magnet that having north pole or south pole both. In the same way, this part, if broken into, it will not divide it not as a only north pole, but it have a north pole and south pole both. Now again if you break this magnet into two parts and this also into two parts, this small part acts as a complete magnet and it also having south pole, north pole. This part also behave as a north pole and south pole. In the same way, this also means whenever you break the size of a magnet, it will again stays at a north and south pole. Means we can't separate the poles of a magnet, it always stays together. Next property is, like pole repel and unlike pole attract. If you see that two magnets are given, 1 and 2, like everywhere. Okay, so if we kept a magnet facing north direction and south direction, that means these are the two poles. They are two different poles, they get attracted. But if we kept a magnet in the alignment like north pole and north pole, these two poles are of same nature, and that's why they repel each other. The same way, if south pole and south pole are facing in the same side, they also repel because they are having the same nature. These are the properties of a magnet. Next are types of magnet. These are basically artificial magnets, that are bar magnet, horseshoe magnet, rod magnet, ring, and this magnet. So in bar magnet, poles are located at the two end. Here is north pole and here is the south pole. In horseshoe magnet, if you see the shape, it's like as a U, or this is also like as a horseshoe. That's why it is called as horseshoe magnet. In this, if you notice, there is north pole and this one is south pole. They both are facing the same direction. In rod magnets, also called as cylinder magnet, in this, poles are present at the two end here, in this two end. In ring magnets, one side acts as a north and the opposite side acts as a south. In the same way, this one is north and another is south. There are also different alignments in magnets.